Well, hello everyone. Welcome to the session. I'm really happy to be here, and thank you very much for the time spending our session today. I hope you're enjoying your second day on reInvent. Just a quick housekeeping before we start. This is SUP307, Cloud Optimization with Trusted Advisor and AWS Well-Architected Tool. Just want to make sure that you are indeed in the right room. You know, time is very precious in reInvent. There's so many sessions. Want to make sure your time is well optimized. My name is Steven Salim. I'm a Senior Solutions Architect working for the AWS Well-Architected team. And I'm here today to talk to you a little bit on how you could leverage AWS Well-Architected Framework and Well-Architected Tool on how you can create an optimized workload on AWS. Today with me, I have Arun Rajan, who is the Principal Product Manager for AWS Trusted Advisor. And Arun is going to walk us through a little bit on Trusted Advisor capabilities, focusing particularly on how we can accelerate optimization outcome for our workload. And of course, we are very happy to have Ravi Srivastava today, Managing Director and Head of Product of S&P Global Market Intelligence. And Ravi is going to share with us a little bit about their journey in their workload in achieving optimization, leveraging AWS best practices and AWS Trusted Advisor. So here is a quick agenda of what we're going to cover today. We're going to level set with what is cloud optimization in AWS, and then we're going to talk to you on how you can accelerate optimization outcome. And finally, we'll wrap up today with a quick story from S&P Global on how they have achieved a workload that is optimized in terms of agility, reliability, and cost optimization using AWS services and best practices. All right, so let's get started. So hopefully by now you would agree with me if I say that AWS has offered many capabilities to allow your workload to work efficiently in the cloud. If you think about the recently new release service on Lambda, I think it's called Snap Start. It allows you to basically reduce the time that you need to bootstrap to run the Lambda function, and basically allows your Lambda function to be much more optimized. If you think about all of these capabilities and the others, what AWS has offered, essentially it offers so many possibilities for your workload to become more optimized. That being said, a lot of our customers, when they first started their journey on AWS, some of the questions they ask is that, are we leveraging this capability on AWS effectively? Are we really taking advantage of the available opportunities to become more optimized in cost, performance, or reliability? Are we applying the right practices when we're working with these capabilities to ensure that our workload are able to meet the objective, but in the most optimal way? And if you think about the number of options that we have today, you can see where these questions are actually coming from. We have about 200 plus services now on AWS. And if you look at these services as a potential capabilities and opportunities for you to be optimized, and also the growth rate on this number of services. This is a figure of the number of service and features that we have released since 2011. You can see that these numbers are growing exponentially. And if you take into account all these two aspects, the question that we'd ask is that, how can we keep up with this? What's the mechanism that we need to use in our approach to optimize our cloud workload to ensure that we're able to keep up with this continuous stream of optimization opportunities? So this is why our approach in AWS, when we're working with optimization, essentially we're working towards alignment on AWS best practices. And it is done in a continuous iteration manner. Essentially what we wanted to do is we want to continuously and iteratively work our workload towards capabilities and practices that allows it to become more optimized. And to create these alignments, what we basically need to do is we need to learn from AWS best practices and find out what are the capabilities and practices that are important for our workload to be optimized. And then we need to measure these capabilities and our current state against these best practices and find out the areas of deltas so that we can continuously improve and over time create better alignment to these best practices. So this learn, measure, and improve is essentially an integral part in the way we approach cloud optimization in AWS so that we are essentially able to keep up with the stream of new opportunities to become more optimized. So now, what do we use to help us with these best practices? Well, in AWS, we have the AWS Well-Architected Framework to help guide you towards areas and capabilities of best practices. If you haven't heard about AWS Well-Architected, It's essentially a collection of high-level best practices that you could use to help you guide, build and run workload on AWS. And you can also use it to also look at certain things that are important for optimizations. And the best practices in Well-Architected are spread across 6 different pillars. As you can see over there, we have operations, security, reliability, cost, performance, and most recently, sustainability. This essentially represents all aspects around your workload that you would want to consider when you're actually building capabilities around it. And within each of these pillars, what you'll find is a construct we call design principles. That really acts as a high-level goals on what sort of capabilities that you wanted to have for your workload to be optimized. And the best practices that are constructed in the framework are really created to become a guided directions towards achieving that state that we describe in the design principles. So perhaps to give you an example on how this works, I'll walk you through a quick example. So over here we have an example of one of the reliability pillar. And inside the reliability pillar, we have 5 design principles, actually. But the one over here we have is automatically recover from failure, which essentially sets up a direction for your workload to have the capability to recover when a failure occurs, but do so in an automatic way. And let's say you want to do this in a disaster recovery context. What is the thing that you need to consider around your workload to ensure that it is able to automatically recover? So the first thing that the best practice guides you to do is to ensure that you have an RTO and RPO defined. So if you're not familiar with this term, it stands for recovery time objective and recovery point objective. That really means how long that it takes for you to recover your system and how much data that you could afford to lose. Now these data points, these measurements are really important because it sets a direction on what strategy that you're going to use to actually address them. And there's many strategies and models that you could actually implement to help you in this RTO and RPO, such as active-active, active-passive, or the most common one is probably to run a backup restore strategy. And from here, you could leverage this direction to actually look at the vast range of AWS services and actually look at the technology stack that you will use to perform the automation activities. And if you're running on backup restore, for example, and if your workload has got a combination between on-premise and EC2, then you can perhaps look at AWS Elastic Disaster Recovery. But if it's predominantly EC2 instances, then perhaps AWS Backup is more for you. And of course, the last thing and the best practice that guides you to do is to continuously and regularly test and validate those implementation end-to-end by running game days or running a continuous test against the configurations using services like AWS Resilience Hub. AWS Resilience Hub allows you to essentially look at your application and workload configurations and measure it against the RTO and RPO target that you have. So this is just a quick example on how the well-architected best practices essentially guide you towards an optimized direction. In this scenario is for resiliency on your workload. Now, if you notice in this example, and it also applies to other design principles in AWS Well-Architected, the scope on the best practice actually spans beyond just technology stack and direction, and it gives you direction of what services to use. This is because for your workload to actually become optimized, it actually requires a combination between people, process, and technology. And this is precisely why the Well-Architected Framework, to help you discover the current state of your workload, and your organizational structure and also your process around your workload, the framework provides you with essentially a set of questions that you could use to have a discussion with your workload stakeholder. And these discussions typically is what we call the AWS Well-Architected Framework review. Now, the objective of this review is really to uncover what is the current state around the workload on the context of organizational structure, the people, process, and also the technology stack that it has. So to access these questions and best practices, you could use the AWS Well-Architected Tool. So the tool gives you a direct access to all of these best practices and questions to essentially help you guide and drive effective conversations with your stakeholders. And apart from that, it also gives you a mechanism to align, to measure alignments from the data points that you capture on this discussion towards the AWS best practices. And it also helps you track improvements over time around the reviews that you've done. So to give you an example, to give you a better picture on how this works, this is the AWS tool console view that I've shown on the screen. So how this works is that with AWS Well-Architected Tool, you can access them directly from the console or via an API. But if you access them via the console, this is how it looks like. And you would create a workload construct in the tool. And once you've created that workload, you'll be able to access all the set of questions and best practices, as you can see here. On the left-hand side of the console, you'll find groupings of all the questions based on the pillars of Well-Architected Framework. And you can really use this as a direction on area of focus that you would like to conduct a review on. So let's say if you want to run a review on optimization first, perhaps for review on your cost reduction purposes, then you could run cost optimization first and in whichever order that you'd like. And this is also quite useful for you to identify who are the right stakeholders within your organization that you need to engage for this conversation so that you can find out, to ensure that you're able to extract the right information when you're discussing with them. So in each of these questions, you're able to find basically a context of what the intent of these questions. And over here, this is actually the questions that we use to find out what is the best practices for the disaster recovery that we have before. And underneath that, you will find the itemized best practices that you could use to select and measure the current state of the workload against those best practices. And this is also quite useful for you to actually scope out your conversation to ensure that you're covering all angles on the specific objective. If you want to find out more around the context and purpose of each of these best practices, then you can have a look at the right-hand side of that console. It will show you descriptions of that context. So beyond this, the tool also provides you with some resources on AWS capabilities and services that you can use to actually support the state on the best practice. So this is particularly useful to set a direction on what set of capabilities out of that 200 and plus that you wanted to do to use for your workload. And it gives you a sort of direction of context on what capabilities are needed for this best practice. To give you an example, this is the automate recovery best practice, which really sets out for you to ensure that you're leveraging automation to address the disaster recovery strategy that we have. And if you're using active-active or active-passive and you have a workload that runs on DNS, then you could use the DNS configuration failover features on Route 53 that essentially allows you to failover any DNS traffic to a passive node in the event of a disaster. So this is just how the tools can help you direct into what set of technologies and sort of practices holistically around your workload to ensure that it's well optimized. So beyond this tool, beyond these capabilities on finding out these questions and best practices, the tools also give you capability to measure. And as I mentioned before, cloud optimization is essentially a continuous journey of optimization. Therefore, being able to track and measure those improvements over time is really an essential part. It gives you a better mechanism for you to focus, as well as justifications for your business if you need to actually make those implement those changes. And for that, the tool essentially gives us features called AWS Well-Architected Milestones, which really is a construct or a way that you can create a point-in-time snapshot of all the information that you captured during those reviews. So it captures all the best practice, the questions that you've captured, and the notes as well during those reviews. And most importantly, it gives you visibility on how far aligned that you are with the AWS best practices. And this is measured in the high risk and medium risk items, as you can see. And basically, as you iteratively run AWS Well-Architected review and continuously create improvements on the workload, what you'll find is this high risk and medium risk over time to become lower, essentially deeming your workload to become more aligned and optimized to AWS best practices. So that's that. That's a quick overview and the run through on how AWS Well-Architected Framework and Well-Architected Tool can essentially guide you towards the people, process, and technology aspect around your workload, ensuring that it's well optimized for the cloud. Now, just a quick recap before we jump into Arun's section to talk about Trusted Advisor. Basically, like I said, cloud optimization is a continuous cycle of learn, measure, and improve towards alignment on AWS best practices. In these best practices, you can use AWS Well-Architected Framework to guide, as a guide. To actually measure the current state of your workload and also measure them and track them against the best practices, you could use AWS Well-Architected Tool. And once you've done this measurement, what you will find is that you will find areas of improvement opportunities, basically areas that you need to improve around your workload from the people process aspects. And the next thing that you need to do on these opportunities is to actually take actions towards path to improvements. And sometimes these path to improvements can mean that you need to enable a certain service, such as, let's say, enabling guard duty to check on your security posture of your environment. Or sometimes it can actually take more than just one step of configuration. Now, in that scenario, what can you do to actually accelerate the outcome? So this is where basically finding out insights around your environment and also your resources are essentially going to help you reduce the heavy things that you need to do to make that decisions to move forward and achieve those outcomes. And one of the tools in AWS that you could use to provide you insights around environment and configurations is Trusted Advisor. And with this, I'll hand over to Arun to explain more about Trusted Advisor and how we can help you accelerate the optimization outcome.
Thanks, Steve.
No worries.
Hi, everyone. Good afternoon. I'm going to connect the dots on what Stephen just talked about with respect to the cloud optimization cycle and how to accelerate that. But before I do that, I see a big room here, and I'm sure there are folks that have used AWS Trusted Advisor, and there are folks that aren't as familiar. So I just want to take a 3-slide hiatus to explore and baseline AWS Trusted Advisor so we're all on the same page. And then we'll continue the story that Stephen started painting. Yeah? So AWS Trusted Advisor can be thought of as the central home of AWS best practices. What this means is AWS Trusted Advisor has a repository of best practices that aligns with the well-architected best practices that Stephen talked about, and it automates the discovery of deviations from these best practices. So it codifies and automates this by scanning your accounts, scanning your resources, your resource configurations, and the usage of these resources to then compare that against a given best practice and provide you with the deviations and the alerts that then you can decide what to do with. Like, you can decide what type of action you want to take to mitigate and optimize for your cloud optimization. AWS Trusted Advisor is a global service. What this means is we aggregate data across all regions for you in a single place. So it doesn't matter which region your workloads are, and if your workloads span multiple regions, we aggregate the insights in one location. Also, let's look at how you can access Trusted Advisor. There are 3 main ways in which you get access to the results. One is through the management console. So you have a visual where you can look at a single account aggregated across all regions, and you can look at all the deviations at a resource level for each best practice that it covers. The notion of a best practice in Trusted Advisor is in the form of a best practice check. So we have checks that cover best practices, and you can see all of that in the management console. In the management console, you can also download reports across all the accounts in your organization. So let's say you have organizations with hundreds or thousands of accounts. You can consolidate all of that and download that as a report. Trusted Advisor also supports the API. So you can pick which checks you care about, which best practices that are important to you, and then pull the data and the results for those checks. And then lastly, there is EventBridge integration. So you can set up EventBridge alarms, EventBridge data flowing in, and you can choose what action to take. Simple actions like setting up an SNS notification for an alert for the checks you care about, to more complex actions like remediation through a script that's run by Lambda that is triggered when a check goes red or yellow. Trusted Advisor today supports 5 different categories, very much aligned with the well-architected categories. So you have cost, performance, security, fault tolerance, which covers a whole bunch of resilience best practices, and then service limits, which helps protect you from quotas as you hit these quotas, before you hit these quotas for various services. Lastly, these best practice checks have three possible statuses. It could be green, which means Trusted Advisor did not detect any deviations from the best practice based on the logic that the best practice checks for. It could be yellow, which implies that Trusted Advisor looks at these deviations, but we didn't have enough data to either ascertain that that deviation needs further action, or we don't believe that it's high enough where you might want to investigate further and then decide if you want to take action. And then lastly, the red status implies that Trusted Advisor believes there's strong evidence to support that there's a deviation from the best practice, and you can actually take action depending on your business context. Now, why do I say business context? It's because the action depends on the mission-critical nature of your business, what environment you're running your business in, what you want out of it, how much risk you want to take compared to the cost associated with the risk. So Stephen talked about DR strategies with active, 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 passive, and backup restore. So those are the kind of choices that you have to make based on your workloads. Stephen also touched upon the increase in the number of services and features within each service. So Trusted Advisor, in accordance with that, also continuously looks to expand on best practices and add support for new checks as new features are launched or new services are launched. Today, Trusted Advisor has support for 272 checks across 45 different services, and we're continuing to evolve that. So that's, as I promised, 3 slides to baseline all of you. Now let's get back to the story. I'm going to introduce 2 personas here to connect the dots with what Stephen said. One is a reviewer, a well-architected reviewer, if you will. This could be a person in your organization that's helping track and tackle the well-architected reviews by asking the questions and capturing the answers. It could be a solutions architect from AWS that's helping you out with the same need, or a third-party partner that's motivated to help you figure out if all your workloads are well-architected. The other persona is an application reviewer or an application architect that's going to answer these questions. So let's take an example of a couple of categories or questions that a well-architected framework review might ask off of you if you are the application owner or the application architect. A perf 2 is, how do you select your compute solution? Cost 6, the question for cost number 6 is, how do you meet your cost targets? That is, what speeds and feeds do you choose? Once you've decided on a compute solution, what size do you choose? How many of the particular instances do you choose? How do you configure it, et cetera? So let's dig a little deeper in a hypothetical journey into this. Let's say you figured out that Lambda is the right solution for you. It's the right compute solution. Now, a follow-up question that could come up as part of the review is, do you know if your Lambda is memory optimized for cost and performance? Now, if you've used Lambda before, or if you've read about Lambda, you'll know that Lambda pricing is based on 2 things. One is the amount of memory that you ask for the function to use, and the second is the runtime. Now, these play very closely with each other, because if you ask for more memory, potentially you could decrease the runtime. Why is this? Because Lambda also allocates CPU and other resources proportionately to the memory. So it's all allocated proportionally. So by increasing the memory ask, you're effectively increasing the CPU ask. So it's not a straightforward answer on what memory config you should use for a given workload. It takes some effort, some baselining to figure that out. It's not uncommon in this situation for an application owner to provide this kind of an answer. No. When we launched the Lambda function, we evaluated the need and picked a memory size, but we haven't touched it since then. The workload may have evolved, the code might have changed, but we're still continuing to use it with the same original memory size. Not a great answer, but it's not uncommon. Now, how do we flip that no to a yes? This is part of the cloud optimization cycle, right? In the absence of a tool like Trusted Advisor, you would set up some kind of a configure monitoring phase where you would look at CloudWatch, say, metrics, other metrics that you might collect from the OS or other agents. And you will stitch together all that data that will tell you about how your Lambda function is running over time. You would establish a baseline. So depending on your particular job or your workload, does it evolve? Does it change? How often does it change? What's a good look-back time period? Is it 14 days? Is it 3 months? That also impacts your answer. So you would establish a baseline. And then based on that baseline and the collected data for each Lambda function, you will figure out what the optimal memory configuration is. Now, not a great answer. Why? Because this takes you away as an application owner and architect from focusing on the value that your business is delivering to your customers. So we want to take that undifferentiated heavy lifting away from you so you can focus on what matters to your customers. That's where Trusted Advisor comes in. So let's take a quick segue into a couple of examples of checks, of best practice checks that solve for this type of need. Before that, I'm going to baseline again, real quick, one slide on what a check looks like. What are the constituent elements of a check? So a check has a check description, which tells you about the context of the best practice, the service, and the best practice itself. It has a source. So if you remember, I told you, AWS Trusted Advisor is a home of best practices across AWS. Now, you have best practices in various locations. It could be in documentation. It could be in a particular service sitting as data. Or it could be in a hub, like AWS Security Hub or AWS Compute Optimizer. Trusted Advisor integrates with many of these hubs, so you have one central location to look at all deviations from best practices. So in this example, it's Compute Optimizer, but that source can change depending on the best practice check you look at. And in this particular example, it also means that you need to have enabled Compute Optimizer for you to see the data, for the data to start flowing into Trusted Advisor. The next is the alert criteria. So this tells you very clearly what business logic is used to detect those deviations. Why do you get alerted? And what condition needs to be met for you to be alerted, or the inverse of it, for you to be green. The other field is recommended action and additional information. So now you have alerts. You have resource level alerts. What do you do with it? How do you go learn about the next phase of remediation for those opportunities? That's where this comes in. This provides you with what are the actions you could take. There may be more than one. There may be one clear one, depending on the check. And what additional information can we help you with, like links to a service, links to some blogs, some white papers, some articles. All of that can help you. And then the last component of a check is the resource level table. This tells you each resource that's impacted, what the status is. Some checks can have multiple statuses depending on the condition being checked. And it gives you additional data, so you can use all of that to make an informed decision on the action you want to take. So let's look at the Lambda check that optimizes for over-provisioned memory. So this particular check alerts you if you've over-provisioned your memory. So it tells you if there's opportunity to reduce the amount of memory you've asked off of the function. How does it know that? Because Compute Optimizer has an ML-based algorithm that looks at, by default, last 14 days of usage of spin-up of your Lambda functions. If there's at least 50 spin-ups of your Lambda function, 50 invocations, then they have enough data for that ML algorithm to then put into effect what optimization could look like for you. And so that ML algorithm then looks at the data using your usage metrics, the runtime of the Lambda function, and how much memory you've asked, and then calculates, is there a better, optimal, more optimal memory configuration that could save you money? Compute Optimizer goes both ways. It can size up or size down. It's a right-sizing service. So this particular example shows you the size down, where you can reduce the amount of memory and save on cost while having zero impact on your runtime. There's a corresponding check in Trusted Advisor from Compute Optimizer that also gives you the performance benefit, where you could increase your memory ask and reduce your runtime without impacting cost. So both ends exist in Trusted Advisor. This particular example is for over-provisioned. And that's what the alert criteria tells you, is how it calculates that, why it alerts you. And it also leads you to Compute Optimizer, where you can learn and configure more. So I mentioned look-back period of 14 is default. When you say, hey, I've opted in for Compute Optimizer, it automatically starts flowing data in based on the last 14 days. But let's say your workload varies not over 14 days, but to get the full range of the variation of runtimes for your workload, you need 3-month look-back period. You can go configure that in Compute Optimizer, and that data will start flowing into Trusted Advisor. The recommended action is fairly straightforward here. If you have determined that this is the right course of action, then you change the memory configuration to the lower one. And let me go back 1 second. And you can see in this example, the Lambda function has been requested with 1,024 megabytes, but the optimal recommendation is 848. And so you can choose to change that memory configuration and save 6% off of your monthly cost. You can imagine now, like, this may seem like a small amount. Now, over multiple Lambda invocations across different Lambda functions across your accounts, this could add up really quickly. And so that's a decision you have to make on making that change. And the idea is your runtime won't be impacted by this change. Let's take another example. This time we'll talk about resiliency. Like, we talked about cost and we touched upon performance, but let's talk about resiliency. It's a common test configuration to deploy your RDS instance if you want a database in a single AZ with some data that you're testing against. So let's say it's a sandbox environment. This is completely fine. But if you have a mission-critical workload that you're running that depends on this RDS database as the data layer, then you have to think about single points of failure. And one of the single points of failure is single point of availability zone failure. So as you can see in this example, the RDS instance, the database instance is in a single AZ, which means if there's a failure in that AZ, it can take down that RDS instance, and you're cut off. You don't have write, you don't have read access to that database. So depending on the need, depending on the business context, depending on whether it's a dev or a production account, you might take the decision to go multi-AZ and spin it up as a cluster. RDS provides this out of the box. All you have to do is follow a wizard and set it up. RDS has 2 settings. One is multi-AZ instance, and another is multi-AZ cluster. With multi-AZ instance, you spin up one other standby, and RDS will automatically detect any outages and flip to the standby and make the standby your primary. With multi-AZ cluster, which is what I'm going to show you here, you can actually set up 2 read standbys. With your single instance multi-AZ, you can't have a read standby. It is just a standby that's waiting to take over if the primary fails. All your reads and writes are through the primary. But with a cluster deployment, you can actually decrease your vulnerability to single points of AZ failure, but you can also increase read bandwidth, read throughput. So you could choose to use your read standbys for your read endpoints, and your writes can happen straight to the primary. And if there's a failure in AZ2, and if that takes down your RDS instance, RDS will detect it and spin up one of the read standbys as your primary. And it'll automatically, after a short downtime, start routing all your traffic to the read standbys as your new primary. Now, why did we talk about that? Because there is a AWS Trusted Advisor check that inspects all the RDS instances in all your accounts across all your regions and tells you if there is a deviation. It alerts you if there is a RDS instance that's not configured with multi-AZ setup. Now, again, business context is applicable here. You decide, based on the RDS instance and what it's up to, if you want to spin it up as a single AZ, and you're OK with that risk, or you want to have a multi-AZ single instance standby or a multi-AZ cluster setup. I also wanted to talk about bidirectional. Since we were talking about well-architected and trusted advisor, there's bidirectional integration between the 2 services. So I'll speak about one direction here, which is many of you may be application owners, application architects. So as you review your workloads in Well-Architected, those reviews will show up as Trusted Advisor checks in Trusted Advisor. Why is this important? Because in your organization, there's DevOps builders, there's central governance teams, there's IT leaders, there's application architects. What this does is it lets all of these personas collaborate. So your DevOps builders and central governance teams that come into Trusted Advisor will now see all the workloads that you've reviewed. Stephen spoke about the milestones and the plan and the review stages. They will see all that as a summary here. And that'll trigger conversations on how do we help reduce high-risk issues that you've detected through Well-Architected. What can we do about workload A or workload B or workload C? And so that's one direction of integration. And with this integration, you have 4 different checks across 4 different pillars in Trusted Advisor, one for each category: cost, security, performance, and fault tolerance. The other direction integration, I'm very happy to announce that in November, just a few weeks back, we launched an integration between Well-Architected and Trusted Advisor, where Trusted Advisor check results show up as status summaries in your Well-Architected console. So now you can imagine, connect the dots to what Stephen was talking about. You're going through a Well-Architected review. You're answering a question. Now you can see, once you turn this, it's an opt-in. So once you configure it and set up that integration, you see that data flowing in as corresponding Trusted Advisor checks for the best practice that you're reviewing. So it's not a drop of all Trusted Advisor checks. It's the specific checks that map to the specific best practice that you're reviewing. So you'll see a tab like that, Trusted Advisor. When you click on that tab, in this particular example, the best practice is perform data backup automatically. So it'll add all the checks that apply to that best practice. So in this case, you can see it shows you Amazon EBS snapshots. It shows you the S3 bucket provisioning and the RDS backups check, all of which could apply. And it gives you a summary, and then you can go click through and go to Trusted Advisor and look at the details. So this helps arm you with evidence, with data, to decide what kind of action you want to take. It also speeds up your review, because now you don't have to go digging into your environment, figuring out what you configured. Let's say you had configured it a while back, and let's say it's been evolving. Maybe there's multiple owners. You can figure out through the Trusted Advisor check what that data is telling you. Now let's connect back to that story, right? We talked about Trusted Advisor. Stephen talked about Well-Architected and the cloud optimization acceleration cycle. How do we accelerate that with Trusted Advisor? How do we flip this no to a yes? You can start leveraging Trusted Advisor to then say, if you're asked this question, have you configured your Lambda optimally for memory, for cost and performance? Yes, because we inspected Trusted Advisor checks that correspond to that best practice, and we know we've taken an informed decision on what matters to our business, and in the context of our business, we've changed the configurations to be more optimal. And that's where Trusted Advisor can help solve that for you. You heard Stephen talk about Well-Architected. You heard me talk about Trusted Advisor and bridge that cloud optimization acceleration story. Now I'd like to very happy to invite Ravi on stage to talk about how S&P Global Market Intelligence actually took these concepts, took these tools, and integrated them into their people, process, and environments. Ravi?
Thank you, Arun. It's a pleasure to be here. I'm very happy to share our journey. This has been a cloud migration journey for us. So a lot of the concepts that Arun and Stephen talked about, we learned through a period of 2 years, going through iterations of design and significantly leveraging the Well-Architected tool, and then later on Trusted Advisor. So let me start by just sort of introducing who we are. You probably heard the name, our company's name, S&P Global, a whole lot. We are S&P Global Market Intelligence. It's one of the 6 divisions within S&P Global. We are world-leading provider of financial information and solutions. Lots of products, lots of businesses within the company. You can probably categorize them into sort of 3 buckets. We either have data or analytics that we sell to our customers. We have enterprise technology. These are software solutions, SaaS platforms, workflow solutions that our customers use. And then lastly, there's expertise and advisory, which is sort of consulting services, experts who sit with our clients in helping solving their problems. Within solutions or enterprise technology, I lead a product or lead a business rather called Global Markets Group. Global Markets Group provides financial technology solutions to banks and the likes. If you know how the secondary market works, if you're going to trade, let's say, AWS stock, you go and put your order in a brokerage account. Before that AWS security is available, it is actually created in the primary market. So we have workflows that allow issuers to issue IPOs or to issue debt to raise capital, and that's what our workflows do. The workload that I'm going to talk about or give you an example of is IssueBook, which is the leading provider for primary issuances, fixed income primary issuances in the world. What it is a real-time platform. Issuers, syndicates, banks, and investors come together to rapidly discover price and trade these orders and allocations in real time. It's multi-tenant, it's multi-region, and we have 90+% of issuances go through either our network or the book building platforms globally. To give you a size of what this really means, in 2020, which was one of the biggest years for fixed income primary issuance, $4.3 trillion worth of issues went through either our network or our platforms. So it's significant enough, and it's a core market component. As I said, I'll cover three topics. All of these came in through iterations. All of these came through a journey. They're not just linear in any sense. There's a lot of back and forth. I'll show you the before and after pictures of how our infrastructure evolved. On the left, you'll see what the on-prem infrastructure looks like or looked like pre-AWS. It's a typical client-server environment. Each client has a server. The server is really a bunch of applications bundled together, deployed as sort of one instance. It's on a data center, so with a fixed number of machines, one machine can run either one or more servers, depending on the volume or usage requirements. The problem or the challenges here that we sort of run into is if you got to make small changes, if you got to make sort of quick changes, it's quite complex and error-prone and risky to build and deploy this quickly with sort of limited automation. I mean, usually you have sort of your Linux RPMs and so on and so forth running, but the blast radius, should something go wrong, is fairly large. And so we were running into sort of a lack of agility, a lack of ability for us to make changes to our environments and features that we couldn't release to our clients quickly. As we went through these architecture sort of sessions, as we consulted with solution architect at Amazon and our internal architecture offices, we adopted a couple services. As you go through your journey, you'll realize there's almost too many choices. So at some point in time, you pick one and then you try and optimize it. So first thing we did is we started using containerization. What that allowed us to do was it allowed us to decouple the application that had to be built as one, but allowed us to now break the complexity of having to manage this deployment altogether. If a container goes down, the managed container services enable you to bring them back up. You're not on the critical path, and there's a lot of resiliency that sort of comes out of the box with it. We also used infrastructure as code, so we automated the entire pipeline. What used to be earlier sort of Linux RPMs and our engineers having to go log into each machine and deploy these installs one at a time now is fully automated. So that brought the whole complexity down. It reduced the blast radius. It makes possible to make quick, smaller changes, reversible changes quickly, and we've actually increased the frequency of deployment. This is a very big platform, so we'd do no more than 2 or 3 releases a year. Now that number has come down to our ability to make even patches is within days or weeks. So that's a great outcome. The second thing is reliability. As I alluded to in my sort of last slide as well, on the on-prem infrastructure, there's a lot of manual, high-touch deployment challenges. Those challenges also bleed into how we execute our DR. So should a DR event sort of happen, our ability to quickly recover and make the, go over to a sort of a secondary site was quite error-prone. Couple that with the fact that I think a lot of on-prem installs are like so. Our primary and secondary were sort of in the same region, right? So we had resiliency, but we didn't have high availability because of that. As we went through well-architected review, and where well-architected review really helped us was it gave us a way to keep track of all the opportunities we had to make our deployments and reliability better, how to improve them. Again, we used Fargate to manage our containerization. We automated, again, infrastructure as code with Terraform. It allowed us to provision the resource quickly, which used to be a problem earlier, given every time you'd have to provision new hardware, you'd have to make a request, go to a VM, go to a different team. All of that with infrastructure as code becomes quite easy for you to provision on your own. We also use managed services. So with Fargate, the services are sort of ramped up and ramped down so more automatically. Arun was talking about RDS. We leverage RDS. We've actually deployed it across the region. So not only do we have resiliency within high availability within one, we actually have across regions as well. So if you have to fail over, we can fail over from North America to Europe or Europe back to North America should the need be. The next one is cost. I think as most of you or some of you or a large number of you will certainly be intrigued or be motivated by a lack of transparency into cost. Data centers are costly affairs, and in large organizations at least, you don't have visibility into where those costs are coming from. What does it take to run these machines? You get a flat bill, and you don't have a way to sort of optimize it as you manage your workloads. Again, through because of the adoption of AWS or how we sort of went about doing it, it became easier to adopt a pay-as-you-go model. So as the volumes in the markets increase, we have the ability to ramp up resources or ramp down resources through infrastructure as code or through our tooling. It allows us to have visibility into cost, and it gives us almost on a real-time basis what the usage statistics are. Arun talked about Trusted Advisor. There are two particular instances where we continue to use Trusted Advisor, EC2 instance utilization and EBS volume usage. Both of these, there are instances where we've deployed it for our infrastructure. And in a lot of cases where we've seen the usage go below 10% over the last sort of 2 weeks or 3 weeks, we've been able to tweak and then get to a utilization which makes sense for our applications. Lastly, what have we learned through all this? So while the benefits are sort of obvious, everything that Arun and Stephen talked about, everything that I'm talking about, it looks, like why won't you do it? And you certainly should do it. I think for us, and for me in particular, the challenge has always been all software development looks easy, and it is to a large extent easy to build, but to run a mission-critical application in production is not. Especially when you're migrating off of a 10, 20, 15-year-old legacy architecture from on-prem onto cloud, requires a whole lot of change in approach, a whole lot of change in tooling, a whole lot of change in culture. So this, to us, has been a journey of change management. This has been a journey of transformation. And this has been a journey of really coming up with a new operating model of how we manage this sort of global mission-critical app 24/7 for our clients. from tooling to DevOps now sitting more firmly within product and engineering teams, to coming up with new roles and responsibilities for our teams that otherwise were organizationally split across, is something that we'd had to manage quite deliberately and tweak as we move along. Before I give it over to Stephen and Arun, the couple things I'd say is, while all of this has been a has been a journey and a learning in progress, tools like AWS Well-Architected Tool and the Trusted Advisor analytics do make it easier and manageable. They give you a line of sight. They give you a sort of an actionable insight for you to go, make changes. It's easy to say we need higher resiliency. It's easier to say we need lower costs. It's easy to say I need to have transparency into cost. But saying that and actually being able to see it and then being able to do something else or action it is not that easy. And I think that's where, to us, Well-Architected Review, the partnership with AWS, and tools like Trusted Advisor have significantly helped us. So with that, I will hand it over to Stephen, and thank you very much.
Thank you, Ravi. Thank you, Ravi. That was really good. Thank you for sharing the journey on workload on S&P Global. Well, folks, we've reached the end of our presentation. Hopefully, this has been some useful insights that you can take away. Before we wrap up, just a quick summary of what we talked about today. Essentially, cloud optimization is a continuous journey of learning, measure, and improvement your workload towards alignment on AWS best practices. And in AWS, for best practices, you could leverage AWS Well-Architected Framework to give you direction and pathways towards what capabilities that you need to build around your workload from people, process, and technology for it to become optimized. And to measure the current state of your workload, you can run Well-Architected Review, supported by AWS Well-Architected Tool, that can allow you to measure the current state and also track those improvements over time. And finally, when you're running those reviews and you're creating those improvements, you want to leverage tools that can provide you insights such as Trusted Advisor to actually accelerate the outcome for your optimization. And here is a couple of resources that you can take away as well. If you want to find out more about AWS Well-Architected Framework, there's the QR code and the tool QR code as well. And especially on Trusted Advisor, you can also take a look at that one too. If you want to find out implementation samples around AWS Well-Architected, on what are the different models that you could actually do on implementing well-architected best practices in your account, then we have a well-architected lab, which is really a collection of step-by-step guides that you could actually use on different scenarios to actually give you a picture on how you would actually implement scenarios to achieve optimization. And lastly, if you need further guidance, or perhaps you're having technical difficulties, whether it's related to well-architected or not, or Trusted Advisor or not, and you need some help from the community, then you can check out AWS Repos. It's a community-driven sharing site for AWS questions, and you could use it to unblock your technical questions. With that, thank you again for coming into our session. I hope this has been useful. Please don't forget to let us know your feedback. We'll be available for questions if you have. Thank you.